Morning guys, I'm the Tech Prepper. Hope you're all doing well. It's been a couple weeks since I've been able to put together a video, but today we're going to talk about how I've gone through and try to do some pseudo-scientific tests on finding the perfect Raspberry Pi 3B Plus case for the field for extreme temperatures. And I haven't quite succeeded, but I need to start operating again in the field. So we're going to walk through kind of all the data I've collected and the approach and all that good stuff. But before we get started, I have a few channel announcements. Number one, I want to thank George and the crew over at the Ham Radio Workbench. They had me on the podcast that just aired this past Tuesday, and we talked about field day, a little bit about EmComm tools, and there was a light interview. Now, it is a long podcast, so feel free to listen to the whole thing, but I'll put some timestamps in the description, or in the description. Yeah, in the description. The portions that I'll be in the show, but the whole thing was fantastic in my mind. So take a look at that. So I'm planning on putting together some mugs for the channel, and I kind of want to get a sense of what's involved, how to do that. And I'm considering two different types. One is a porcelain mug, and the other is a single-walled stainless steel mug, because I love to take out those types of like nesting cups and mugs out with me into the field, and I think it probably speaks more to the prepper roots of the channel. So let me know if you guys would be interested in something like that, and if you would prefer porcelain or stainless steel single wall design. And what I'm planning on doing is doing a comic strip style series that touch on prepper topics and also ham radio, and I have a few cartoon drawings I've been sketching out of my notebook here. The other update is I really want to thank everybody who's been following me on buymeacoffee.com/thetechprepper. You guys are amazing, and the reason why I was able to do this video is because of the donations there and support, and I was able to buy about 5 or so different cases for this video. All right, so before we get started, let's look at some context. So first of all, I am a man-portable field operator. I live in the Sonoran Desert. Right now in the summer, I'm experiencing temperatures in the early morning in the mid-90s Fahrenheit, up to about 115 degrees Fahrenheit, sometimes a little bit even higher than that. I do like to operate for short windows of time, so I don't run digital very often or very long. I typically just do a 5 or 6 minute session to get an APRS packet out to communicate with my wife over the SMS gate text message bridge. And then I do WinLink. WinLink on HF usually takes about 20 minutes based on my historical use of that system. And that's pretty much it. Outside of that, I might keep the Pi running to do things like offline call sign lookups that are available in the EmComm tools project. But really, the intent is not to run FT8 or full duty modes, at least for me. So all of this testing is based around that. Number two, I've never been a gamer, so I don't have a whole lot of experience with overclocking CPUs, thermal paste versus thermal glue, heat dissipation with vent-cooled heat sinks and water cooling. This is just based on me running into an issue when I added CPU telemetry support to the EmComm tools project, and I noticed that the Raspberry Pi, right from a cold boot, was really at around an operating temperature of about 95 degrees Fahrenheit, and then would quickly climb pretty quickly and then kind of plateau in the default configuration. So that's where I'm coming from, guys. So if this video is not for you, maybe I'll catch you on the next one. So what were my considerations? So one was cooling. So I wanted to figure out what was the best way to dissipate the heat on the CPU specifically. The Raspberry Pi 3B Plus, the CPU package, has a max operating temperature rated for, I believe it's 185 degrees Fahrenheit. And I never hit those temperatures. The highest I hit was around 140. Power consumption, if I decide to use a fan, I do run my entire man pack off of a 4.5 amp hour BioWino battery. For power distribution, I have it connected to the BuddyPole Power Mini, the first generation, and I'm using the USB, I think it's a 2.5 amp USB 5 volt connector which causes some problems with under voltage on the Pi, but doesn't really disrupt the actual use. So keep that in mind. I am experimenting, or will be experimenting, with the new Buddy Pole Power Mini V2, which is 4 amps, so that I could test the Raspberry Pi 4 with the Argon 1 case. And that's another important note. We're not going to discuss this one today, but it's something now that I have metrics and a baseline on the 3B Plus, I'll be able to go ahead and talk a bit more about this one in the future. So there will be an Argon 1 Raspberry Pi 4 evaluation as well. So we talked about cooling, power. Size is also a consideration. This is about the footprint that I want to keep because I do have to pack it out in my man pack. Weight is not a consideration for me. I already carry too much weight, and going from a case like this to an aluminum case doesn't really mean a whole lot to me in the grand scheme of things. Ingress protection is absolutely something I need because I'm out here in the desert. I operate man portable, and there's a lot of dirt around. So there are some cases like this guy here. I think this one is the Unistorm. Yeah, the Unistorm case. And it actually exposes a lot of the materials or a lot of the components. So we'll talk about this in a minute. So let's move on now to my approach. So I wanted to have a pseudo controlled environment to start with. So first things first, I did instrument some logging within my Raspberry Pi. I created a cron job that runs once a minute, and it dumps the timestamp and the CPU temperature of the first core every minute, and then I graph that data later. I decided to document my findings in this Moleskine notebook. I have about maybe 10 or 15 pages where I record basically time, date, environmental conditions, things of that nature. I did experiment with a number of cases. I think I did 4 cases in total. We'll talk about each of those individually here in a second. And then the conditions there were really 2 conditions. One was in my home office, which typically meant that I was working with a temperature range of 79 degrees to about 80 degrees Fahrenheit with cooling in the house. And then I also did try a couple of experiments in the RV where the temperatures were around 100 degrees Fahrenheit, which is closer to what I would expect in the field. Now, I have not had a chance to test this experiments in the field. I will be doing that with the Pi that I have selected, and there'll be a follow-up video on my findings on how that works in practice. Let's see, conditions. We talked about telemetry. Oh, and then let's talk about the system. So I'm using the Raspberry Pi 3B Plus. Vintage is from 2018. I'm running Raspbian OS Buster. And then in terms of services, there are a few services that I automatically have on startup. And that is GPS-D, or the GPS daemon, PAT WinLink, the RDOT modem, and then my EmComm tools software. And we'll talk about the impact of running those services on startup as it relates to CPU temperature here in a bit. I also decided for determining the environmental conditions, I'm using a really reliable temperature gauge in the house. It's the one I took for field day, and it kind of ran alongside me. And again, it didn't vary more than 79 to about 80 degrees Fahrenheit, so within a degree or so, which was kind of nice. And then all of these experiments were unattended, where I basically started the timer, turned on the Pi, and let it collect metrics for 1 hour with a 1-minute sampling. All right, guys, so I have 3 Raspberry Pi 3B Pluses, and I've always bought them in kits from CanaKit, and it was just because my prepper roots always tell me to standardize on equipment. And really all you get is a plastic case from CanaKit and a small CPU heatsink and heatsinks for the GPU, and I believe one other onboard circuit. So this was the baseline, and I let it run for an hour like all the other tests, and the mean CPU temperature was 127 degrees Fahrenheit, so pretty high in my mind. The min was 101.4 degrees. The max was 134.4, and then the standard deviation was a huge swing at 7.74. All right, guys, sorry, there's nothing I can do about that dog. So this was the baseline. I ran 3 tests like this over a few days, and they all pretty much had the same results. So bottom line is, this is not a case that I'm going to use. All right, so the next case is from IUniker. Here's a spoiler. This is going to be the case that I personally am going to use for a number of reasons. We'll talk about that later. But I ran about 3 tests as well with this case. This one is unique in that it has a small 5-volt fan. And while it is noisy, it did have pretty decent results inside the house. So I had a mean temperature of 103 degrees Fahrenheit, a min of 99.5, a max of 105.2, and a standard deviation of 0.92. So the temperature swings on this one were very small, so very consistent graph, whereas the CanaKit basically just peaked and stayed at that peak and never cooled. Alright guys, if you're still with me with all of the barking dogs, airplanes, helicopters, and all the noise I get out here in the country where there shouldn't be any, thank you so much. Alright, the next case, this is interesting and something I struggled with. This case is the Unistorm case, and it offers passive cooling through a full aluminum case enclosure, as well as active cooling with the fan. And this one was 100% the top performer. And if I had to use something in the house for the Raspberry 3B Plus, it would be this case. It's not ideal for the desert and outdoor operations, and I'll talk about that in a minute. So very cool. Like I said, it has a aluminum base on the bottom, an aluminum base that sits on top. There are 2 models, one that does not have a fan, which I don't have, and one that also has the optional fan. And it gives you 2 fans, and you can run these on either the 3-volt or 5-volt GPIO pins. Now, the mean was 97.2 degrees Fahrenheit, which means on cold startup, this basically runs as if it was on cold startup all the time. The min was 95.7 degrees Fahrenheit, max 98.6, and the standard deviation 0.56. And that was consistent across the 3 tests that I ran on it. So really cool case. In fact, the fan isn't very noisy. The fan on the IUniker, extremely noisy. I also ran another test without the fans, just as a baseline. And the mean for that was 99.87 degrees Fahrenheit with a min of 93.7, max of 101.4 degrees Fahrenheit, and a standard deviation of 1.8. So really quite nice, and if I had opted for this, it would be nice to also have a fan or a case that didn't require power in the field. Now, the reasons why I can't use this case in the field is that it completely exposes the GPIO pins, and that can be remedied with a cover, but there are other components that were just too exposed, and I wanted to have ingress protection for dirt in the Sonoran Desert. I also haven't found an answer to this question, so maybe you guys can help. The other thing I found is when I did testing in the RV, this case got incredibly hot, like up to like 130 degrees Fahrenheit. At least that's what the CPU was reading, and extremely hot to the touch. So I don't know if the heat present on the aluminum enclosure would actually have negative returns and cook the CPU when the ambient temperature is in the degrees or the temperatures that I'm working with. So I'm very cautious and leery of the aluminum cases for that reason. So if anybody knows, I would absolutely appreciate, and again the question is, does a aluminum heatsink enclosure, when exposed to high ambient temperatures, inversely impact the CPU in any way, because it is very warm to the touch. In fact, I don't even want to drop this back in my bag. That's how hot it was, because I do have the battery and other plastics in there. But again, great case if you're using it in the home, and I'll probably keep this one around for that use case. All right, guys, greetings from the future. I misspoke about the Flirc case, and we'll re-record this piece on its own. So I decided that since I had good luck with the aluminum enclosure when running inside the house, I would try another case that was along those lines, but wasn't fully enclosed in aluminum. And this case actually has a plastic material on the bottom and top. It does not have a fan, but it does have a full contact with the CPU package, and then offers the majority of the case as a heat sink for heat dissipation. I really had high hopes for this one because it was also fully enclosed and offered good ingress protection. The metrics were not quite where I wanted them, so the mean temperature was 105.1 degrees Fahrenheit, the min was 98.6, the max 107.2 degrees Fahrenheit, and then it had a standard deviation in the house of 1.93. I ran a similar test in the RV for a 1 hour period, and the mean temperature there was 102.9 degrees Fahrenheit, a min of 99.5, a max of 129.5 degrees Fahrenheit, and then it had a large standard deviation of 7.18. And the heat, at least the perceived heat when I would touch the case, was also much higher than I wanted, and something I don't want to expose to ambient temperatures. So I won't be using this case in the field, but I had really high hopes of it. The other test that I did was I also baselined the power consumption. So just running the Pi for an hour in my configuration with the software, I was actually drawing about 0.26 or 260 milliamps, which actually isn't too bad. And for the systems that have the fan, like the one I'm going to be using now, the difference was something like 10 milliamps. So not enough draw on the fan or with the fan to make a case either way, even with my small 4.5 amp hour battery. So really high hopes of this one. In the future, I may revisit this one and try to rig something up with the fan that I'll mount inside and run off of 3 volts or 5 volts and see how that works. But yeah, unfortunately, because I really love the look, the feel, and the protection. All right, let's go back to the past and check out the recording from this morning. So ultimately what I've decided to use for the field is the IUniker case that runs with the fan. And about the only modifications I've done is attaching some dust covers. So I have one for the HDMI port. Since I run this headless, I don't need it. The audio interface here, which I also don't use. And then I've covered the RJ45 Ethernet port, and then one of the USB ports. And I'll put a link to where I got that on Amazon. I think I got like a 40 piece unit of miscellaneous dust covers. So kind of cool. Outside of that, the other thing I've decided to do is similar to what I find in the field. Since the ground temperatures are so hot, I typically have to evacuate a little bit of dirt and put my sleeping pad, which doubles as my sitting pad, so that I could have some insulation between me. I've taken my wife's yoga mat and I cut off a strip, and I'm actually going to run the Pi on top of that, and then also put this on top of probably my bag or a place that's not in direct contact with the ground. So that's kind of where I'm at. Let me take a quick look at my notes here, make sure that I'm not missing any critical observations. Oh, yeah. So a few observations here. So I mentioned at the beginning that the operating temperature for the CPU package is a max of 185 degrees Fahrenheit. That only applies to the CPU package, not to the other components, not to the SD card. And my research has shown that the component that's most likely to fail in these ambient temperatures will be the SD card. So I'm going to start making more clones of these because there is a very limited lifespan of these SD cards when exposed to those ambient temperatures. I don't want to, I'll try to put a reference of, I'll put a reference here on the numbers I found for some of the SD cards on what the expectancy is in terms of life in those environments. The other thing I'm going to do is I'm going to continue to use all of this gear in the field, so there will be an update video, and there will be also a separate video on the Raspberry Pi 4 and Argon 1 case. This one is very promising. I like the fact that all the connectors are on the back, and it's also using an aluminum case plus active cooling with a fan. There's contact with the CPU package, so this will be coming shortly. A note on software, I also found that if I stop the RDOT modem, which is required for PAT WinLink for HF, that the overall CPU temperature drops on average by 1 to 2 degrees Fahrenheit. So one change I will be making is that my Pi will no longer start up in WinLink HF mode by default. I would rather have it have a lower CPU operating temperature, and then when I need to perform a WinLink operation, just enable it with my one-click operation on the EmComm tools package. Alright guys, I apologize for all the noise. I don't know how any of this is cut together like most of my videos, but it's been a few weeks, and I just wanted to share some early results, and not terribly scientific. I don't have a whole lot of experience doing these benchmarks, but these are just my observations, my thoughts, and based on how I plan to use it, I'm going to be going with I'm going to make sure this is the IUniker case. Yes, I'll be going with the IUniker case, and I'll put links to that below if you guys want to support the channel through Amazon. Alright guys, I'm the Tech Prepper. Be strong, be safe, and be prepared. Did I just confuse the cases here?